Just to review for chapter test 1. If point B is on the interior of angle CAD, then measure of angle CAB plus measure of angle BAD plus measure of angle CAD. That is the angle addition postulate. Who is considered to be the father of geometry? That is Euclid. Insert the missing word from the postulate. How many lines go through any 2 points? Exactly 1. If 2 distinct lines intersect, then they intersect in exactly 1 point. If 2 distinct lines intersect, then they intersect in exactly 1 point. That question should not be on there twice. Through any 3 non-collinear points, there is exactly 1 plane. This postulate develops a number line in which each real number is paired with the point, and each point is paired with a real number. The development of this number line then allows us to measure segments. That's the ruler postulate. This is the segment addition postulate. The survey that divides an angle into 2 smaller congruent angles. That's an angle bisector. Points that lie on the same line are collinear points. These are 2 angles whose sum is 90 degrees, complementary angles. Blank figures are figures that have the same size and same shape, that is congruent. Points that lie in the same plane are said to be coplanar. When you have 2 or more geometric figures that are blank is the set of all points that the figures have in common, that is intersection. This is a geometric figure that extends in 2 directions forever. Some characteristics that does not bend, curve, or break. That is a line. A blank is 2 adjacent angles whose non-common side form a straight angle or line. That is a linear pair. The blank of a segment is a point that divides a segment into 2 congruent segments. That is a midpoint. A blank is represented by a flat surface that extends without end and has no thickness. That is a plane. A blank is a geometric figure that identifies a location in space, has no size, it's a point. A blank is an accepted statement of fact, that is a postulate. This is a section of a line that has 1 endpoint and then extends in 1 direction without ending, that is a ray. A point, plane, line, ray, or other segment that intersects a segment at the segment's midpoint is said to be a bisector, a segment bisector. This geometric figure is a section of a line that has 2 endpoints. That's a segment. This is the collection of all points. That is space. These are 2 angles whose sum is 180 degrees. Those are supplementary. Those are vertical angles. Which is not an appropriate name for the line. E. Okay? That is not an appropriate name. Lines have to have 2 endpoints, or 2 points on the line listed. It doesn't matter the order, and you need a symbol of a line above them. Segment has endpoints S and V. The only one that's talking about segments here is option C here, or the 3rd one. Name the segments in the figure below. Not a segment. Look at the symbol MO. That works. MO works. Nope, that's a ray. That's a ray. That's a ray. PQ. Nope, Q is not on that line. MP. Yep. MQ. Nope. NP. Yep. MN. Not a segment. Not a segment. NO. Yes. OP. Yes. I use the DCG. Okay, DCG is going to be this plane over here. And EAB is going to be this plane back here on the left. For those, there is no intersection. It'd be option B for me. Obviously, what you need to do, if they said this plane in front, maybe they said EAD, and then DCG, maybe we're talking about that plane again on the side. Well, they intersect there. Okay, so some of you might have had an intersection. Okay, look, draw your picture, shade in the planes that they're talking about, and then see where they come together. A postulate that any three non-collinear points lie in one plane. Using the figure to the right, find the plane that contains the first 3 points listed below, then determine whether the fourth point is in that plane, right? Coplanar, non-coplanar. So QRT. So QRT is in the plane, or sorry, QRT. Those 3 points for me are not they're not all 3 in the shaded plane here, but 3 non-collinear points are always in a plane. But then I put V here, so Q, R, and V are all in this plane here. Okay, but T is outside that plane. Okay, so these things would be non-coplanar. Graph the points. Okay, you're going to grab your little tool over here, and we're going to plot -2, -1. So -2, -1 is right there. And then we're going to plot again -1, or sorry, 1, -2. So it's right there. And then the last one is 3, -6. Is right there. And then obviously those points we would choose to be non-collinear. They want to know, find RS. Okay, they tell me ST is 18. So this is 18. RT, the whole thing, is 44. So to find what RS is, I'm going to take 44 minus 18. Figure that out, type it in. Here they say RS is 7y plus 2, and ST is 3y plus 7. RT, which is the entire segment then, is 12y minus 1. What you're going to want to do is set 7y plus t plus 3y plus 7. Okay? This segment here, which is that information there, plus that segment should equal the total of 12y minus 1. You get 10y plus 9 there is equal to 12y minus 1. I'll add 1 to both sides. I get 10 over here. I subtract 10y from both sides. I get 2y. Here I get y to be 5. If y is 5, that's going to be 35 plus 2 is 37. This will be 3 times 5 is 15, plus 7 is 22, and then this will end up being 59. Okay, so then you can go ahead and fill in those pieces of information. Okay, here they're saying T is the midpoint. So if T is the midpoint, that section there and that section there are equal. So PT was 4x plus 6. TQ is 6x minus 6. Solve that equation, and you will end up with PT being 30. Okay. All we have to do here, if I want to find DAF, I'm going to highlight where that ray goes through and where that ray goes through, and I'm going to subtract 180 and 90 and then take the absolute value. 190 being that number, 180 being that number. Okay, I could also use 0 and 90. Subtract those and also get 90. If I want EAS, I'm going to look at where EAS goes through. Right there. Right there. Okay, so that's what, 110, and this is going to be 155. Absolute value of that then will give me 45. RAE, and we'll look where R goes through, or AR, that ray, and then ray AE is that ray. So now that's going through 40, and this one's going through 110. So subtract 40 and 110. So 40 minus 110, I'll take the absolute value of that, and it provides me 70. You would do the exact same thing to get these two. Okay, here they use a little bit of a different notation that we're used to. Usually we put a number in there, and we talk about it as that number, but they're just using a W, and they put it in there so we know that that's the angle they're referencing. So I need to find another way to name that angle. Well, I start at C, and go to U, and then go to T. That's one way, and then I can go in the reverse order. Start at T, go to U, and finish at C. Make sure that you don't say angle U, because there's actually 3 angles there that have the vertex U, so I have to be specific. I'll name this angle in 3 different ways. Again, FED, DEF, angle E. I don't know why they use a lowercase letter here, but it should be a capital letter, but there should be no confusion there. They're still labeling that point there. LKR, we're looking for an angle congruent to LKR. LKR is that angle there, so I'm looking for an angle that has 2 markings in it, and that angle is right there. Okay, and I can call that several things. I call it MQP, I call it OQP, the angle MQP, angle OQP. I call it PQM, and I call it PQO. Angle PQO. Okay, any one of those will work. It will accept all 4 of those. I just can't say angle Q because there's multiple angles there that share vertex Q. Here they say it's a straight angle. So if it's a straight angle, they're supplementary. So I'll take 12x plus 2. Add to it 7x plus 7, and they should equal 180 if they're supplementary. 19x plus 9 is equal to 180. 19x equals 171 then. Go ahead and solve for x. Plug it back in then for the 12x plus 2 and the 7x plus 7. And then you will be able to determine that they're 110 and 70 respectively. So always, sometimes, never questions. Collinear points are always on the same line. That's the definition of collinear points. When 2 planes intersect, they always intersect at a line. That's part of the postulate we had. So that has to be true all the time. If a point is on the intersection of 2 lines, then the point is always in both planes. If a point is on the intersection of 2 planes, then the point is always in both planes. Think about a wall and a ceiling intersecting. If we put a point on the corner where they intersect, that point would be in the wall and it would be in the ceiling, so it would be in both planes. So that's always. If B is between A and C, then AC plus BC equals AB. That is never. Think about drawing a picture here. and C, and then B is in between. So what this is saying is that AC, that amount, plus BC, that amount, should equal that amount. Well, obvious by what we just traced out, BC plus AC is going to be much bigger than just AB. So that's never true. If two lines intersect and the two lines are always, sometimes, never coplanar, never non-coplanar. They are never non-coplanar. If two lines intersect, then the two lines are contained by the same plane, so they have to be coplanar. So be careful with these words. Alright, so this would be never. If I wrote coplanar like that, if that was the question, then you would say always. Okay, so just be careful. Name a pair of angles that are a linear pair. Basically looking here to see which of these angles form a straight line, and that's AFC, which is this angle here, AFC, and then DFC, which is that angle there. They both come together to form that straight line. Use a diagram. Is this statement true? 2 and 5 are vertical angles? No. Okay, the rays that form angle 2 are not opposite rays of the angle, or the rays that form angle 5. Okay. So now remember, kind of think about vertical angles. They look like reflections of one another. 2 does not look like a reflection of 5 in that question. Here they want to make the conclusion. Does JKH, J to K to H, this angle here, is that congruent to L to K to H? Can I make the argument? Okay. Well, there's no notation inside that red angle and that green angle, so no, I cannot make an argument because there's no markings. If they asked me about this angle here and that angle there, then yes, I could say there's something I could say about they're congruent. But the markings indicate that. These lines here, okay, that segment and that segment could be said to be congruent because they too have the congruency markings for those segments. But the angles in this particular question are not congruent, or you can't say they're congruent because they don't have the correct markings. Here, these angles are a linear pair. So if they're a linear pair, we said we had a postulate that said all linear pairs are supplementary. So we're going to take that angle, add it to that angle, set it equal to 180. That means that's a linear pair. Those two angles are supplementary. I get 8n plus 44 is equal to 180. Finish the math there. Find n. Okay, when you find n, you should be able to plug it back in for here and there and end up with what those measurements are. Here they've got, they're telling you that GH is an angle bisector. Well, angle bisectors take an angle and cut it into two congruent parts. So this angle here and this angle here have to be equal. So 2x minus 5 is equal to 3x minus 19. Add 19 to both sides, you get 14. Subtract 2x from both sides, you get x. X is 14. That's what we're showing here. Plug back in 14 to that x and to that x, and you'll be able to find that FGH is 23, HGI is 23, and then the total angle FGI is 46. Here, again, they're telling you got a bisector. It says BD bisects ABC. So we got ABC and BD bisects it. So D has to be out here somewhere. And they're telling me ABD is 8x minus 6 and CBD 6x plus 2. If this is a bisector, then this angle is congruent to that angle. It's like 8x minus 6 equals 6x plus 2. Solve for x, you'll get x to be 4. And then plug back in to find ABC. Okay, the way I would do that is I'd plug in here and then there. Okay, find those two smaller individual angles and add them up, and I get 52. 8 times 4 is 32, minus 6 is 26. 6 times 4 is 24, plus 2 is 26, 26 plus 26, 52. Find the midpoint. Remember, we're in the coordinate plane here, so midpoint is going to take your x's and add them together. Okay, so negative 3 plus 5, and then divide by 2. Then you're going to take your y's, add them together, 2 plus 4, and divide by 2. So it's going to be 2 over 2. It's going to be 6 over 2. That reduces to 1 comma 3. Remember your midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. Okay, find the coordinates of the midpoint of this segment. Okay, here, this is just one number line. Okay, so that formula was a plus b over 2. Well, a and b are the coordinates of your points of your segment, your endpoints of your segment. So I'll take negative 6 plus 9, divide by 2. That gives me 3 over 2. Add your endpoints. Divide by 2. Find the coordinates of the other endpoint. Okay, and this is a little bit trickier. They tell me the midpoint is 217. So I'm going to use this formula. x1 plus x2 over 2 and y1 plus y2 over 2. Plugging things in, the midpoint I know is 217. They tell me x1, this is x1, this is y1. x1 is 9, I don't know x2. y1 is 15, I don't know y2, so I'll let them be those variables. Now we know this is an ordered pair, this is an ordered pair, they're telling me they're equal, so that amount must be the same as that amount. So I'll take 9 plus x sub 2 over 2 is equal to 2. This amount here must be the same as that amount. So I'll take 15 plus y sub 2 over 2 and set that equal to 17. Multiply both sides by 2 down here. I get 9 plus x sub 2 is equal to 4. X sub 2 then has to be negative 5. Down here, 2 times 17 is 34. So I get 15 plus y sub 2 is 34. Subtract 15, y sub 2 is 19. So negative 5, comma 19 is the ordered pair for the other endpoint. Find the distance. Remember your distance formula is subtract your x's. Okay, the distance, we don't have a name for these points, so I'll just say distance. And then you subtract your x's. So x2 minus x1, square them. Add to it then your y's, subtract your y2 minus y1 squared. And remember, it doesn't matter the order that you subtract your x's or your y's. So I'll just take 3 minus a negative 3. I'll square that. And in my y's, I'll go 13 minus 13. I'll square that. Well, 3 minus negative 3 ends up becoming 3 plus 3. And this will give me 13 minus 13 is 0. So 3 plus 3 is 6. So take 6 squared, 0 squared. Well, 6 squared is 36. Square root of 36 is 6. So the distance here is 6. Same idea here. We're going to use our distance formula. x2 minus x1 squared plus y2 minus y1 squared. Subtract your x's, so I'll go 19 minus negative 11 squared. Add to it negative 10 minus negative 20 squared. 19 minus negative 11, well, that's going to give me 19 plus 11, which is going to be 30. So 30 squared. And then negative 10 plus 20 will give me 10 squared. Keep the square root of those. So that's 900. And that's going to be 100. So I'm going to the square root of 1,000. And your calculator will give you that to be 31.622277. They went to the nearest thousandth, so that's the third decimal place. So 1, 2, 3. That's the one I went around. I look at that number, it's a 7, so I change that to a 3. And that's what we're showing there in our answer. And the last question. Determine if the statements are true or false. A linear pair, all linear pairs are supplementary. That's true. That's a postulate. That we have to know. All supplementary angles are linear pairs. That's false, because you could have an angle here that's maybe 110 degrees, an angle over here that is maybe 70 degrees. They are supplementary, but they're not a linear pair. Remember, a linear pair has to be a straight line. They have to be two angles that form a straight line. They have to be adjacent. The two angles that I have here are they're supplementary, but they're not adjacent. So no, they're not going to be a linear pair. You could have, angles like this where maybe this is 60 degrees here and that's 120 degrees there. Okay. Now that's 60, 120, they add to 180, but they're not a linear pair. Okay, they don't form a straight line together. Okay, I'm looking at that angle and that angle. They're not adjacent, so they're not a linear pair.